So we earlier we talked about memories and how computer understands and counts in binaries, and then let's talk about memory uh, in a computer sense. Computer have a couple major storage, but two major storage. We have the hard disk, like where you store your stuff. If you've ever heard, if you've ever been around for quite some time, you would hear of hard disk. We used to call, they're now called storage easily, and then computer also have a different kind of storage that is now called memory. It used to be called random access memory. And the analogy about that is, take for instance, you have a table in your office, and then you have like a drawer also in your office. So on your table, you're probably gonna keep things that you use randomly that you can access easily, and then on your drawer, you're probably gonna be keeping historic stuff like old files and stuff. So that's the same architecture a computer works at. The storage, also known as your hard disk, is where things that are not really random or that you don't use randomly are. So in a sense, you could actually pick something off the drawer and put it on the table and use it and then return it. So that's basically how it works. AI works the same way. Because AI are pre-trained models, there is always a need for it to be closer, because whenever you're using it every time. So AI is trained of billions and billions of data. So putting those memory in a place that is easy to take, is like on your table, would be challenging, because number one, it's big. Imagine, of course, your table is always going to contain less things than your drawers or your cabinet. So what happened before the AI revolution? We had, computer had run into some of these problems, and those problems were being shown by, or were being, happened as a result of a lot of gamers. People like playing games with their computer, and games take a lot of graphic, because every little picture that is represented, every little, you probably heard of pixel dot on the screen, is a piece of ones and zeros that is being represented to show you that the color and everything. So NVIDIA had, for some time before the AI revolution, been creating memories that would be able to bring out this data and keep them. Remember, people playing game, we're playing game on real time, we're watching videos on real time. So we're using memory on real time. And the smaller the pixel, the smaller the pixel, the more information it is on your TV. So if you used to watch the TVs then that use very pixelated, you couldn't see very fine, it's because it has less data. But we have learned to put more data, and we have more RAM, so we can show better videos, and we can play games, and games will be happening very fast. So all those things happening live is as a result of you having a memory that is close by, that is constantly sending information to your screen. You're pressing the letter B or A on your joystick, and it's happening in real time. Same thing with AI. So AI came in, trained with billions of parameters. Some of them hold as much as 4 billion. There is a 1 trillion parameter model, Kimi 2.5. Same thing. It has to be in a place that it's able to answer your questions immediately, or it's not going to work effectively. So this is how memory plays in. So cool stuff. My Nigerian brothers, you cannot imagine that Sokatwa that we used to learn in school is a $5 trillion company right now. And NVIDIA was perfectly positioned. And I think it's knowledge that if you had, or it's knowledge, this is why this knowledge is always good. If we had the basic knowledge, we would have understood why NVIDIA went from an $800 million company 3 years ago to a $5 trillion company today.